This set of tools uses ArcGIS Insights to create it rather than dashboards, which was the first two tools we showed in this tutorial. How it differs is with dashboards, you create a web map using ArcGIS Online, and then you build the dashboard around that web map. The difference here is you just put the data straight into ArcGIS Insights, and then you create your maps and you adjust your symbology and those things directly within Insights. So what I found is that Insights is less, there's less customizing in Insights. You have less control over how things look, but it does contain some more powerful charting functions and some data analysis tools that don't seem to exist in dashboards. So there's a bit of a trade-off between the two. This one's a little clunkier to use, but it has a few more powerful things. What Insights reminds me a lot of is Microsoft Excel, and it has lots of features from Excel that sort of create a hybrid of data analysis and interactive mapping at the same time, which is really cool. So this first one uses the same data as the point analysis dashboard, and it's showing the annual percentage of average data. So it's exactly the same data as the dashboard with the points, showing again with 90 to 110% in the yellow color being average, and then anything green and blue becoming above average, and anything orange and red being below average. So the difference here from the other one, the individual points are the same. If you look at any value of any point on the map, it'll be the same as the dashboard. What this does, it's a little bit more powerful than the dashboard, is it creates regional averages. So for any of these polygons showing on the first map here is snow basins, it's averaging all of the points within the polygon automatically. This is very similar to what you'd see on the BC River Forecast Center's monthly maps they put out throughout the winter. The difference here is that this is showing max annual height of snow data, whereas the BC River Forecast Center's maps that use the same polygons are showing snow water equivalent, which is if you were to melt all the snow, how many millimeters of water would you have left? It removes the density factor within the snowpack. But since we're interested in height of snow, we're showing the height of snow data. Where this becomes powerful is as you change the filters, it automatically updates the average value within the polygons for whatever points are left. So the first select a year option here will only let you select 1 year, and it always defaults to most recent year. So we're looking at 2021. Again, depending on the type of analysis you're doing, you may want to turn off snow courses. We have a lot of data here, so I'm going to turn it off. Right away you can see a different picture, right? We see more reds come in. It's important to note though, Vancouver Island's a good example here. Because we turned this filter on, we can see there's only 1 point showing. So that 1 point is showing 51%. So it's well below average, almost half below average. If we highlight the value for the actual polygon, it's exactly the same. And that's because there's only 1 point. So it's important to look at how many points are actually in the polygon. In this case, I would not say Vancouver Island is at 51%, because it's only based on this 1 point in the north of the island. On the other side, so here's this is the South Columbia, Kootenay region. We can see probably close to 10 points in this polygon. So I would be a lot more confident looking at the average value based on these points in this polygon. Where this becomes interesting is I've chosen to show elevation categories as well as max HS values. Again, this is like if you want to turn off dry stations and only look at the wetter or the deeper snowpack stations, we can do that. And what we see here is once we've filtered out points in areas in the polygons where there's no points, that they no longer show up, right? So now we can just see the polygons with points still remaining in them. It's not as fast as dashboards. It has to do the calculations as you're adjusting the filters, but it's pretty quick. What I've found most useful is just to look at elevation bands. It's often what we're interested in a given winter. We may not necessarily be interested in the average of everything. We may want to compare. So in this case, this is again 2021, just low elevations below 800 meters. And we talked about this in the other video, that low elevation stations in this most recent winter were well below average throughout the interior. We see that same trend here. We see a lot of reds and oranges in southern BC when we're only looking at below 800 meter stations. A big part of this, I believe, is just freezing levels. We got a lot of rain last winter. A difference of 1 or 2 degrees can be the tipping point in southern BC for, whether our preset falls is rain or snow. So one, thing I like to do here sometimes is take the snipping tool, keep that open, and then change this. So now I want to look at just the high elevation stations, say above 1600 meters or maybe above 1200 meters, and then bring back the low elevation. So there we can compare the two. We can see a different picture where most of our high elevation data is at or slightly above average, and most of our low elevation stations are well below average here. So that's one way we can use this to compare elevation bands. Like I said, we can compare dry stations versus wet stations. We can turn on and off the different types, and we could add additional filters to this. There's no limit to it. The second map is the same set of tools, just showing different polygons. In this case, we're looking at the avalanche regions through BC. Same point data, different polygons. And it's interesting because you actually can see different trends just depending on where those polygon boundaries are drawn. So again, we're looking at 2021. One of the disadvantages of Insights here is we have to create filters for each map. We can't create one set of filters that applies to both maps like we did in Dashboard. It's one limitation. But if we want to apply the same filters for 2021, and especially for the avalanche regions, we may be more interested in higher elevations. See a similar trend. A lot of averages, slightly above average, a little bit below average in that southeast corner, like we mentioned previously. So this is pretty cool. This is I'd say a slightly more advanced version of the analysis compared to the dashboard, but it's a little clunkier just to move around the actual tool itself. So, like I said, each of these has its pros and cons, and part of the reason that we have this sort of same data set being used once in Dashboard and once in Insights was really just to compare and contrast and see which tool allowed us to do which things better and which could be improved. So they both have their strengths, and I imagine that in a few years down the road, these things will be merged together, and all of these features will be available in a single tool. And I imagine Dashboard will win out. Some of these advanced charting features and stuff will be brought into ArcGIS, online maps, and dashboards.